This lesson is adding, editing, deleting, and validating data. The objectives for this lesson are to add some methods to our repository class to modify data, and then of course add the routes to the controller class to call those new methods. And we'll add some data annotations to the product class to validate data. Let's add modification methods to our iRepository interface, and then modify our product repository class to implement those methods. Open the iRepository.cs file, and we're going to add an insert, an update, a set values, and a delete method. That means we need to now open up our product repository, because inside of here, since we're implementing that interface, it's going to tell us we need a few more methods. Let's collapse these two, and let's then add these new methods. Now they're just stubbed out for now, the insert method, the update method, but set values actually does have some code. Now this is not necessarily needed in this. This would be more if you're doing a patch. But what this does is it compares the current value in the table with the changes that you're sending in to see if we need to use either the things coming in from the changes, or if nothing came in from the changes, then we need to use the current value that's in the table. Like I said, not necessarily needed for an update, but for a patch, this would be very kind of useful code. And you might have to still make it a little bit more bulletproof. And then we also have our delete that's, again, not implemented yet, but we at least have the basics here so we can compile and we can start building up one by one our add, edit, and delete. Let's now implement the insert method in our product repository class. Locate the insert method in our product repository, and we're going to replace it with this code here. We're going to fill in the required fields that may not be passed by the client. Doesn't matter, we're going to override them. We're going to create a new GUID ourselves, and we'll set the modified date ourselves. We're then going to add that new product entity that's coming in, and we're going to add it to our products collection in the DB context. Remember, that was the DB set. And then we're going to call the save changes method on that DB context. It goes out, sends the insert statement out to the SQL Server, and it fills in any other fields that were generated by SQL Server, fills those back into the entity, and that's what will then return back out of this method. Let's open up our product controller and locate the mock HTTP post that we just did earlier, and let's now replace it with the real one. So what we're going to do here is we're going to do an HTTP post. Now we're going to return a 201 created, or a 400, or a 500. The post, we can put the from body attribute there in front of product if you want, although with MVC it is actually the default. It assumes that the entity is coming in from the body. What we're going to do is serialize that entity right away into our entity as JSON. We're then going to test to see if the entity is not equal to null. If it is not null, we then attempt to update the database, right? We're going to call our insert method that we just wrote on our repository. And then if everything works okay, we're going to do a status code of 201 created, passing back the entity. Otherwise, if the entity is null, we're going to send an info message with a bad request saying, hey, the product object you passed is empty, because that's not valid. So we want to let them know that they sent a bad request, which is the 400. We'll also log that information as well. And then down here in the catch block, so if something goes wrong in that code up there in the try, we're going to, of course, set an info message that we can say something went wrong in the post here, and in the error log that we're going to send down there to our error log will be exception trying to insert a new product, and we use that entity as JSON that we serialized. So again, we can then take a look at what they were attempting to send. And then, of course, we pass all that to the handle exception, and that returns the 500. So let's test this out and see if everything works. We'll now click on the post, try it out. We're going to fill in the request body now with some valid data. So name is a new product number is new 01, color is blue, standard cost is 10, etc., etc. Let's go ahead and click on the execute here. And if everything works correctly, we should get a 201 back, along with, look at that, our response body, and it has the product ID filled in. So Entity Framework takes care of getting that identity that was generated, and it sends it back and puts it into the appropriate property for us automatically. If we now go over to our AdventureWorks Lite database in SQL Server and we take a look at the product table, and we select all the rows here, we could be able to go all the way down here to the bottom, and we will see the new product that we just entered right there on row 295. It's 36373. That was the ID that came back to us. A new product, new 01, blue, 10, 50. So all the data has been inserted into SQL Server. So I'm going to keep track of this number here, and then we'll use that when we update and we delete. Let's now add the update method to our product repository class, and then of course, create our route in our product controller. Locate the update method and let's add in the following code. We're going to set the last modified date to the current date and time. We'll update the entity in the products DB set by calling the update method and passing that entity. And then we call the save changes on the DB context again. And it returns the entity from this method. Let's now go over to our product controller and let's add in a HTTP put now. So again, we pass in the ID here on line 131, right on the method here, int ID, and then from body, again, optional, and product entity. Now look at the produces response types. We have a status of 200, 400, 404 now, and a 500. So there's a lot that can happen inside of here. So inside of here, we first serialize the entity just like we did before. Within the try, we're now going to check to see if the entity is not equal to null. Then we're going to attempt to locate the data to update by taking the ID that was passed to this method, calling the get method on the repository to get the current product. If that current product is not equal to null, we're going to go ahead and combine the changes into the current record. Remember, that's set values. So you can look at that one in the samples. Like I said, not really that important that we do this step as long as the user is sending the full record of everything you want to update, which they should be on a put. If they're going to do just partial, then you'd use a patch. We're then going to attempt to update the database by calling that update method on the repository that we just created, and then we pass back a 200 OK with the current record, the one that was updated. Now, if the current is equal to null, which means it did not find it, then we're going to tell them that. We'll give an info message, can't find product ID, tell them the ID they were attempting to update, and then we'll send back a 404 not found, passing in that informational message. And then again, I'm logging here. You can choose whether to or not. Now, the other else is if the entity sent is a null, then we want to again tell them that by saying product object passed to put is empty. And then we return a 400 bad request telling them that. So I'm trying to handle all the different situations so the user is getting good information about what went wrong with their request. And of course, if we catch an exception trying to do something, we'll send them the generic message back, but our error log message will again have all of the data. That entity as JSON is that, serialized version of the product object, and we will store that in our error log. So let's go ahead and try this out. So we'll run the application again. We then come down and locate the put. Now under products, we'll try it out. The ID was 36373. We're going to modify this. We will put in that same number here, 36373. And then I'm going to change the name to change the product number, new 01. Now I'm not passing everything, so this is where that set values really does come in because I want to be able to keep whatever was there in the record, but these are the changes that I'm now making. So let's go ahead and execute this, and everything should come back okay with a 200. You now see the changed data, and then you see the old values there as well. That was the set value. So I was really kind of doing a patch here as opposed to a put. But I wanted to kind of at least cover both of them at least some point in this course. If we then go over to our SQL Server, we can then re-execute this query. We go all the way down to the bottom again. And we should see now, change the product, the new 01, the red now instead of black. So all the changes did indeed get made. We've done the add, we've done the update. Let's now do a delete on our products. Locate the delete method in the product repository class, and let's add the code to delete a row from the product table. We pass in the ID to delete. We then create a product entity equals underscore dbcontext.products.find, passing in that ID. We'll either get back a valid row or we will get back a null. If the entity is not equal to null, we will locate that entity to delete by doing a underscore dbcontext.products.remove, passing in that entity, and then invoke the save changes method on the underscore dbcontext. We then return a true value. However, if we do not find the record to delete, we will return a false value. Let's now go to the product controller and let's add our new route for deleting. Here's our route where we have the status codes that could be returned are 204, 404, or 500. We pass in the integer ID of the product we wish to delete. On line 192, we call that new delete method we just wrote in the repository, passing in the ID. If it returns a true, that means it was deleted. We then return the status code 204 to the user. That means everything was fine. Otherwise, we're going to create an info message, can't find the product ID with the ID they passed to delete. We send that back with the 404 not found, and we can log it or not as appropriate. Then in our exception, if an exception occurs, we're going to get the message default. That's what we'll send back to them when we send back the 500 from the handle exception. For us, we're going to build our error log message here that says we are trying to delete this product ID, and that's what will be logged into our error log. Let's go ahead and run this one now. Locate our new delete route and try it out. So 36373, we execute. Again, it goes out. And the success is 204. Now, again, if we go over to SQL Server and we execute, we should see now that we have 294 rows. So the one that we had added and updated is now deleted. There are lots of ways to handle validation, but I like using data annotations. These are attributes that we add to the properties to enforce business rules. Now, we've seen data annotations to handle things like mapping a column and their attributes to the column in the table, but now we're going to add them for enforcing business rules. The most common business rules are really already created for us: required, compare, range, min length, max length, string length, email, URL, phone, and credit card. There's probably others out there as well. The complete list for these can be found at this URL. If you just look up data annotations, like for C#, you'll find this URL. Let's add our data annotations for validation to our product class. Open the product class, and let's start out with the name. The name, defined in the database, has a maximum length of 50. So we're going to use the string length here, but I'm going to set another business rule that a product name can't be less than 4 characters. So I'm setting a minimum length as well. And then the product number also has a length of 25, but I want to set the minimum length now to be 3. So these are just a sample of some of the data annotations we can add. So for example, for the standard cost, I want to set the range between 1 cent and 9,999. I might do the same thing for the list price. For the size, I might add the string length of 5. So the max length there is 5, but other than that, it can be whatever. For the weight, maybe I want the range between 0.5 and 2,000, for instance. And we can also do range on date times by using this range type of date time, and then you pass in the values that you want the date time to be between. Now that we've added those, let's go ahead and just run this. There's nothing else we need to do. MVC has all the model binding and data validation stuff built in. So if we now come down here to the post, we try it out, and we put in a product object now with bad data. So the name only has a single character, right? The product number has 2, but we needed it to be 3 or more. The standard cost and the list price are 0, for instance. So there's some bad data in here. Let's go ahead and execute this. And what we get back now is this nice validation object. It comes back as a 400. And now you can see that it says 1 or more validation errors occurred. And then look at the errors property. It's an object that contains a name. So that's the field name. must be a string with a minimum length of 4 and a maximum length of 50. The weight. The field weight must be between 0.5 and 2000. This is all just done with the data annotations. Isn't that great? There is nothing else you need to do to handle a lot of these just very standard business rules. In this lesson, we added data modification methods to our repository class. We added new routes to support that modification of data. We learned to validate properties using data annotations. For more information on data annotations, check out my article at this URL. I wrote that in January of 2023. Coming up next, create searching methods.